Cool. Well, welcome to the March Community Office Hours with Dragonfly and our guest speaker, Mike Perham from Sidekiq. Thank you all for joining and taking part with us today. As we continue this journey each month with different topics and different guests, if you would like to suggest any topics to us, please feel free just to drop us a note afterwards. Feel free to shoot me an email, laura@dragonflydb.io. We're constantly looking for different topics, and if you have ideas what you want to see on these office hours, keep us in the loop. So over to you, Joe, today.
Hey guys, sorry, I was just trying to unmute. Yeah, it's kind of the hardest when hosting sessions. Other than that, I do have personal list where I keep like what I need to do before hosting the session. Things like hiding the bookmarks, hiding the extensions, turn everything into do not disturb mode unless there's a delivery driver banging on my door. I think we're good to go. So yeah, hi everyone, we're very welcome. And as Laura mentioned, we're having our March office hours with very special guest speaker from Mike from Sidekiq. I appreciate your time and appreciate all the attendees, community members' time. So as for
Thanks
today,
for having me, Joe.
No problem, it's my pleasure. It's our pleasure. So yeah, for today we have we try to keep the agenda for the slides slim so that we have more time maybe for the conversation and for questions as well, right? So we're going to do a community update. We're going to do an intro to Dragonfly, Sidekiq, the Sidekiq use cases, Dragonfly integrations, and hope all the community members find this interesting. Cool. First up, we have the community update. As you know, as many of you may know, Dragonfly is a community-driven project, right? So every month we pick, the winner, kind of like the top community contributor, to shout out. And this month we have Fabiano Ahuda. Yes, Fabiano Ahuda. Yes, I remember the pronunciation from the site. Who is a platform engineer lead from a DeFi platform, I believe. And the contribution is related to the help chart for the main Dragonfly repository. So Dragonfly currently runs mostly on Linux. So for local development and for CI purposes, this is a huge improvement, right? So it allows you to render the templates locally on machines where the application is not the target. There's another improvement about the certificate creation process. So it doesn't have to wait for a pre-existing issuer. So yeah, speed up the whole process, I think. And it's awesome work for improving the CI pipeline flexibility and dev experience. Thank you so much for the contribution. It's very much appreciated. So we're looking forward to your next PRs and maybe many more PRs from the community. So yeah, please take a look at the Dragonfly repo. We have the social links for Fabiano over here as well. Feel free to chat with him if you have like some sort of shared interest in terms of platform engineering and maybe the project. Yeah, cool. So yeah, that is the community update for today. And for those of you who don't know what Dragonfly is, we have a very brief introduction here. Kostas, do you mind telling us more?
Yes, of course. Yes, jumping in. So first, hi everyone. I'm Kostas and I'm a software engineer at Dragonfly. For those of you who don't know what Dragonfly is, well, Dragonfly is a modern memory key value store that is a drop-in replacement for Redis. And I use the word modern here because Dragonfly addresses the main pain points of Redis, and it can fully leverage the underlying hardware to achieve vertical scaling, meaning that if you run DF on a beefier machine, that is, if your machine have more CPUs, then it will automatically scale and use the available workforce. And I would love to rant about all of those pain points of Redis, but I will save that for later because there is some interesting things to know between the interop with Dragonfly and Sidekiq. And for that, I would really like to pass the mic to Mike and ask him a little bit more about Sidekiq and why did he start the project, what is it, and why does he decided to use Redis as a backend. So Mike.
Thank you, Kostas, for those kind words in that intro. So Sidekiq is a background job framework for the Ruby programming language. It tightly integrates with Ruby on Rails, so anybody building business applications with Rails would likely be very familiar with Sidekiq as a companion bit of infrastructure for any large scale Ruby application. I started Sidekiq in 2012, and I used Rescue, another open source background job engine. I used Rescue as kind of a template or a starting point for my own design that became Sidekiq. And Rescue was using Redis also. And so I just picked Redis because that's what Rescue was using. That's what everybody else in the Ruby community was willing to install, right? Half of the struggle of building infrastructure is getting your users to be okay with your dependencies. So, Redis was already accepted as a high quality data store. So Sidekiq used it, and we've been quite happy with it for the last decade, with one exception. And of course, that's where sort of Dragonfly is willing to take a little more aggressive stance about fixing some of the limitations that Redis has. But I'll let you guys go into more about that. Does that answer your question?
Yes, 100%. And like the first, I guess, the natural question is, how to basically use Sidekiq with Dragonfly. And I mentioned earlier that Dragonfly is a drop-in replacement for Redis, so the setup is easy as switching to the Dragonfly binary, and then Sidekiq will work outside of the box. But the interesting thing, and this kind of like will set up the conversation and forth, is basically the configuration, right? And what I mean by that is, like, if you really want to squeeze the available hardware, you would need to consider certain Dragonfly configuration flags. And it's important to note here that Dragonfly, uses a certain nothing thread per core architecture, which basically means that no data is shared among different threads. And we have as many threads as the number of CPUs available in the system. And we call each thread with its respective data a shard. And the way we distribute keys is obviously by hashing the key name modulo the number of available shards. Now, in Sidekiq context, you talked a little bit about jobs previously. We have a queue, and its job queue pretty much is represented as a Redis list. And what that means is that if we use multiple queues, we need to carefully distribute them among the available shards, and we need to take into account that each queue has 1 over n chance of adding up into the given shard, where n is the total number of shards available. So we need a mechanism of load balancing the queues among the available shards effectively, increasing the amount of parallelism, right? And for that, we would need something we call the shard round robin prefix, which basically changes the way the keys are distributed among the available shards in Dragonfly. And as explained earlier, the default is to hash and mode, but with round robin prefix, you can distribute the keys that start with a given prefix via a round robin fashion. And this acts, this acts as the load balancer that we so much need. And this has this is very different from Redis, because Redis requires Redis cluster to scale, right? And that's a big pain point. Remember, I talked about pain points of Redis. This is a big pain point because you have to deal with an extra layer of abstraction, and the scaling is not done that automatically, and which increases basically the cost of ownership when you have to use the Redis cluster. So it's not only the performance characteristics, but also the cost of ownership that comes when scaling a system. And Dragonfly, as I said earlier, is naturally faster because it better leverages the underlying hardware, but also it's more memory efficient. And why is it memory efficient? Because an example of that is during replication, right? If you want high availability, you need to replicate your data somehow. And the way Redis is tackling this problem is particularly interesting. So you have the parent process, you have the parent process, and then the parent process forks itself and then starts replicating. But when you fork something, right, in Linux, you share the pages, you share the memory pages, right? Both the parent process and the child process share the memory pages. And the issue with that is during contention, right, when you hit those keys, Linux triggers copy on write. So effectively, in the worst case scenario, you end up doubling the memory required for you to replicate something. And that's, you know, that's fun enough and kind of ironic if you ask me, that, you know, this high contention example I gave you is, you know, is the same, is triggered a lot with Sidekiq, because if you notice, Sidekiq only touches a few keys. So there is high contention among the available queues. And Dragonfly, this, you know, we decided on a different approach that doesn't suffer these problems. So again, the cost of ownership drops significantly because the amount of memory used by the system is way significantly less than Redis. And to top it off, because you get this very nice vertical scaling, in our benchmarks, in the benchmarks that I ran, I tried to, if I remember correctly, I used an 8-core machine, and I've used 8 queues. And compared to, you know, to a single Redis instance, we were 3.5 times faster. And I suspect you can squeeze a little bit the hardware even more. So, you know, if we see that there is a lot of traction with Sidekiq, like for sure we would look for ways to optimize it. But the key takeaway is that regardless of how you look it up, when you how you compare those two systems, Dragonfly will not only offer you better performance, but the cost of ownership will significantly drop. And as a consequence, you're gonna, you know, as a developer, you will be happier because you pay less, you have less things to maintain, like the Redis cluster and so on, and you get, you know, better, basically better utilization of everything. And sorry, I was like kind of like a big talk about around Sidekiq and Dragonfly, but I hope that this captures the you know, the benefits of using Dragonfly instead of Redis with Sidekiq. And that being said, Mike, I have a question for you. Do you think that, you know, the use cases for Sidekiq will change over the years? Do you think, you know, that scalability at some point will be a pain point?
Well, Costas, you just like dropped a whole lot of really deep stuff on us in about 5 minutes, man. I'm gonna need 10 minutes just to recover from that, just to think about all that you said. So good question. I think Sidekiq is a product of its ecosystem, of the environment, and just the idiomatic way that Ruby applications have those design patterns that have become idiomatic within the Ruby community. And Sidekiq reflects those patterns. You know, Ruby doesn't have a great concurrency story, so Ruby's concurrency story is background jobs. We basically use background jobs as a way to spin off, you know, concurrent work elsewhere. You know, Go has Go routines, Java has thread pools, but Ruby, because the threading is not lock free, your Ruby processes don't scale well. So generally Ruby forks, and you spread a lot of work over a lot of different processes. And of course, Redis has this same sort of problem of being single threaded. So yeah, Redis has scaled admirably well with Sidekiq to some pretty incredible levels. I have customers doing hundreds of thousands of jobs per second, but that's with dozens and dozens of Redis shards. You know, they basically have to shard so that they can scale horizontally, because they can't scale vertically due to Redis's single-threaded nature. So that's
here.
Go ahead, Costas.
Yeah, sorry for jumping in. I do have a question. Like, in terms of like, you know, customers, like what kind of ops per second is the highest you've seen in throughput? Like,
oh, ops per second. I don't have a good answer for you there. Yeah, I mean, the numbers, I have customers giving me sort of round numbers of like jobs per second throughput. But I don't have like instantaneous ops per sec like you'd get from the info command. At least I don't remember any in the last few years that would be relevant here.
Okay. Sorry. Continue.
So let's see. We were talking about single-threaded Redis. The other thing you were talking about was data models and network architecture. So Redis supports standalone. It supports Sentinel. It supports cluster mode. But Sidekiq, because you're working with application data, you need a transactional. You need transactions effectively. So you need that multi-command that Redis brings to the table. And unfortunately, that doesn't work with cluster, where you're storing lots of data in different keys. Because when you're storing data in different keys, it could be stored on different instances, right? I'm sure you know this, but I'm not sure how much of the audience knows that. But where was I going with this? The point is that Sidekiq does not support cluster mode, so you can't scale horizontally just by adding nodes to a cluster. Unfortunately, that works with a cache. It does not work with a transactional workload like Sidekiq. And so that's where I when I first discovered Dragonfly and you guys approached me about a collaboration, I thought, yes, finally, someone's trying to take on this elephant in the room and trying to get a Redis that scales to all cores. That's really what I would love to see. I'd love to see that lock removed from Redis. I'd love to see that lock removed from Ruby, and let us use those cores. But yeah, I mean the work you did on that blog post to show all the benchmarks and all the nice speed up that you can get. I was just impressed by the thoroughness of what you guys did, and that's why we're moving forward with this, and that's why I'm happy to help out with Dragonfly and to see where it can take Sidekiq over the next decade.
I'm very, very happy to hear that. And in particular, again, like I didn't want to put words in your mouth, but you kind of said it. Like when I look in the future, I look about Sidekiq and Dragonfly with a big heart. That those two will pair very well, and I would love to see use cases where they want to take Sidekiq workloads to the next level, and then I would love to see Dragonfly being pushed to the limit, getting hammered. And I think this is where it best shows and captures the how amazing Dragonfly is. And sorry, I'm talking I'm talking about it in I'm very happy and psyched about it, but I truly. Because obviously I'm working on the product, but like if you compare it with Redis, like if you look on the benchmarks, it's just so much, like it scales so much better, and I can't wait to see what the future holds, and especially with Sidekiq users. So yeah, that's I guess amazing for you and what you said before. So thank you for that, Mike. Yeah, I don't know.
Kostas, I just want to add that, and thank you very much for your words. By the way, I'm Roman, CTO of Dragonfly DB. Haven't introduced myself, sorry. So I just want to add that we have customers on Dragonfly Cloud running Sidekiq workloads, and this synergy of having customers provides a wonderful opportunity for us to improve and optimize Dragonfly to Sidekiq workloads even more. That's, by the way, what we did with BoolMQ. We announced compatibility, and we continued improving BoolMQ compatibility and performance silently without marketing all the improvements afterwards. But we did lots of good work during November, December, January on BoolMQ, and we also have customers running those workloads in production on Dragonfly Cloud. We'll do the same with Sidekiq. It's important for us to support job management or job processing workloads. We recognize that Redis grew to its popularity because of those frameworks. People really need high throughput and low latency mechanism to share data within the microservices setups, or just as Mike mentioned, because of the limitations of original limitations of the language, but developers need to store this shared data, shared memory somewhere. We believe that in-memory store is the perfect solution for that, and we are going to make sure that it's going to be optimal in Dragonfly for Sidekiq. Yeah, so go ahead, Joe.
Cool, that's amazing. Thank you, Roman. So yeah, let's see if we have like questions from the community. But before that, yeah, like thank you, Mike and Kostas. Like there are a lot of like internals of the optimization that Kostas and the team did, and you can, yeah, that was the blog post that was scrolling through, and yeah, it's available on our side, and yeah, please try, if you're interested, please try installing Dragonfly as well, and we have like a Discord community, Discord server for you to join as well. Yeah, similarly, like you know, please, because it's a collab, it's all about, you know, the open source ecosystem. So yeah, if you have like background job processing needs, check out the Sidekiq's website as well. They have different level of support and features here as well. Yeah, so.
So can I jump in here for a second?
Please, yes, Mike, please.
I just wanted to compliment you guys, because when I first checked out Dragonfly a few months ago, when you guys initially contacted me, I was just impressed at how quick and easy it was to get started. I mean, so many projects just don't do that well, or right, you just don't test that, or you know, the developers aren't installing it day to day, so they don't realize how weedy the installation path may get, right? And with you guys, it was just a matter of, you know, basically using Docker to download the container and start it up, and boom, it was running. And then when I ran Sidekiq's test suite against Dragonfly for the first time, there was really only one thing that broke. Everything worked out of the box without me having to do anything. It was great. The one thing that broke was a command that you guys hadn't yet written. And so you guys took about a month to write that command, so Sidekiq would work 100%, and then boom, Sidekiq was working 100%. So you know, I have nothing but praise for the dev team on the integration.
That's great. Thank you so much, Mike. Yes, that actually that's something, you know, it's kind of like, you know, after the fact, but it's kind of where I was trying to head as well, you know, because Kostas just talked about a whole lot of, you know, the internal optimizations and the effort, and, you know, how to use proper configurations to run. But for me, you know, without this blog post, you know, when I first tried Dragonfly, I had like similar experience as Mike had, which is like I only switched the connection string. You know, that's the thing you need to change in code, and that's pretty much it. Unless, you know, if you're using a very special, you know, a rare command that's not supported by Dragonfly yet. But you know, to me, the connection string should be the only line to be changed in code. Cool. So yeah, so without, you know, saying the throughput and, you know, the optimization, I think compatibility is a very important thing that we keep in mind. As well in terms of the wire protocol as well as the commands. Cool, so back to the slides. Let's see, I don't have more slides. Maybe we can start to take questions from the community. And
I have a question coming in there from Joseph. Thank you, Joseph. If we were to restore Dragonfly from a snapshot or an RDB file, where would we modify the number of Dragonfly threads? Since the snapshot was taken, would that have any impact on Sidekiq's or any other client's ability to read the keys? And are the keys then reshard, based on the current number of threads defined? Oh, that's a question and a half, Joseph. Thank you very much for question posing it.
Yep. 1 second. You mean when you're saying you modified the number of Dragonfly threads, you mean you took a snapshot, shut down Dragonfly, and then you restarted it with a different number of threads, I suppose, right? Yeah, the snap. Yes, correct. Okay. Yes, and then I guess would that have an impact on Sidekiq or any other country with the keys? No, but if you run with less, if you run with less threads, and then you have more queues than the available threads, and obviously the performance is gonna degrade, because let's say if you had 8 cores available, now you have 4, like of course what you expect, your performance will drop. And that's why you should usually let it auto scale, such that you don't have to worry in figuring out the amount of shards yourself. Let Dragonfly do it for you, unless of course you have a reason to. And are the keys then restarted based on the current number of threads? Yes, of course. So for example, if you if you had 8 queues, and then before you had 8 cores, and then also if you use the round robin prefix, you would probably get, you would get 1 queue per core. But now if you drop it at 4, now each of your cores owns 2 queues. So obviously there will be some contention, and this kills the degree of parallelism. Remember, the more CPUs you have, the more parallel requests you can serve. And yeah, I think, does this answer it, or?
Yes, I think so. Yeah, Joseph also said that. Answer this question. Thank you so much, Costas. Yeah, I was having a hard time doing unmute again. Yeah, thank you so much. Cool. Let's see. We have another one
for Mike. So
yeah,
Mike, in the future of Sidekiq, what is the one feature? What's the future of that you're going to be working on that you're most excited about over the coming weeks and months?
Oh boy. Well, Sidekiq doesn't have a lot of new features coming down the pipe. It's mature software at this point. I've been working at going through dependencies and figuring out upgrade strategies for dependencies that haven't been upgraded in 4, 5, 6 years. So maintenance never ends on software, and so if you're not working on your own code, you're upgrading dependencies and doing that sort of thing. So unfortunately, I don't have a good answer in terms of exciting new features, but maintenance is what pays the bills.
That's important. Thank you, appreciate it.
I saw something about Sidekiq just come through.
Just in there from Joseph.
So the question is, Sidekiq isn't compatible with Redis cluster because of the transactional requirement of multi-execution. How does it handle these multi-execution calls, like multi-execute? Those are like Redis or Dragonfly commands, right? Calls against keys that traverse multiple threads.
I guess this goes for Dragonfly, right? How do we handle multi-key operations, basically? Well, this is interesting. In Dragonfly, we have, as I said earlier, we have multiple shards, right? Each core owns a shard. Now, when you have a multi-key operation, you usually, what we do is we distribute a set of callbacks to all of the available shards, and we call this a hop, right? And this obviously introduces latency, because now you need to distribute work to each of the shard, collect back the results, and then return to the caller. So that's basically how we deal with multi-key operations, is that we use hops, and then each distribution of callbacks is called the hop. And then you can have, based on the command that you're building, you might have 1 hop, you might have 2 hops, you might have 3 hops. And that's actually interesting, because one of the optimizations that we found out was that in Sidekiq, as I said earlier, it uses Redis lists to store jobs, right? And it uses blocking commands. And one of the things that we did not do very well was in blocking commands, we had extra hops involved. But if the blocking command was on a single queue, that it was not a multi-key operation, which is exactly the use case of Sidekiq most of the time, that allows us to kind of optimize this further. And I discussed this briefly on my blog post. Is basically we reduced the hop count from 2 to 1. So basically we kind of like reduced 50% the latency of blocking commands, of single key blocking commands.
I just want to add that the semantics of those commands in Dragonfly stays exactly the same. We still provide the same atomicity guarantees, like with a single-threaded Redis, meaning the applications or users of Dragonfly do not need to cope with all this complexity of multi-threading. It's completely hidden from a user. and they perceive Dragonfly as an atomic store, where each multi-exec transaction is executed atomically. Underneath happens a very complicated or executes very complicated algorithm, and we, by the way, provide the reference to the original scientific paper that we based our algorithm on. You can check our README file in our GitHub repository. Check it out. But yeah, we use an algorithm that is fit best for very high frequency and low latency operations like with Redis, and it works very well and scales very well. And we improve it with time, and that's what Costa was explaining, all those various improvements and optimizations that we did with our basic version in order to improve it even further for Sidekiq.
Can I ask a question? Maybe this is a Dragonfly newbie question, but what's your policy on pulling in new Redis functionality if they're adding new commands to 7.2 or 8.0? Do you guys take all that and sort of merge it into your fork, or what do you do?
It's not a rule. Basically, we just decide based on community traction. We had some commands from 7.0 implemented pretty early. On the other hand, some other commands that we haven't heard lots from our users, we just delayed. But I think we are on par with, let's say, Redis 6 plus. And just give you some example. So, for example, JSON extension is not part of Redis open source, but there's lots of interest in that feature. So our team implemented it, and then people were they were asking for search capabilities, and again, it's a pretty complicated feature, and we've been implementing this lately. So yeah, basically, it's very much a dialogue with the community, and that's how we prioritize features.
Yeah, thank you, Mike. Thank you, Roman. I also,
by the way, Mike, you actually experienced that yourself. You mentioned that Redis log in Lua script is missing, and we felt that it's a friction, and we just implemented at least so that Lua scripts won't fail. And nobody before that ever mentioned this, so this is why we haven't implemented. And by the way, once you mentioned, few weeks afterwards, we had another user asking about this feature, and we already had it implemented in our mainline. So basically, this is how we react, and this is how we execute.
I know when you approached me, I determined that the bit field command you guys hadn't implemented yet, and Sidekiq was using bit field for some of its functionality. So yeah, obviously there's another instance where you guys improve your Redis compatibility so that Sidekiq would run without issue.
Yeah.
Okay.
Thank you so much, all the speakers, and yeah, it's very informative session. I think we are approaching the time. Let's see if any of us have like some final remarks.
The only final remark I have is for the community. Join Discord, ping us for any questions you have. Let us know for sure what are the next features that you like. And yeah, just basically just say hi into the community.
Cool.
Well said,
yeah, well said. I guess that's true for both communities, for all the open source communities. Yes. Thank you so much.
Thank you.
Thanks, everyone. I really appreciate you all for taking part today. Thank you.